Well, good afternoon and welcome back. We're going to be talking about the cost of production, but this time we're going to take a look at the long run average cost curve. But once again, I'd like to remind you to read your textbook. Both the long run and the short run are in chapter 9 in your textbook. So also, please remember to practice in your econ lab so that you develop some competencies in this area. So the long run is defined as the time period long enough to enable the firm to vary. Please highlight that word in your notes. Once again, your notes are all found in the handouts in your Econestoga notes material from March 16 onwards. That's where you find all your notes. So to vary the quantities used of all inputs. In other words, this is the planning stage of the company. The long run is where the company plans. There are no fixed factors of production and there are no fixed costs. They are all estimates that the accountants, industrial engineering, and whoever will go through. So the firm can build any size or scale of plant, able to make any adjustments to size of its plant to its scale of operation. In other words, everything is only on paper. It is a plan. The profit maximization firm will choose the minimum cost for each level of output. That is the important factor. The technology that they will be implementing, the size of the plant that they will be building, will reflect the minimum cost. An example could be Linamar, for example, in Guelph, has a number of different plants, more than 13, I believe, and they all have less than 300 employees, or the majority of them have less than 300 employees. They figure that's the best way to operate. Then you take a look at Magna in Guelph, which is Polycon. They have over 1,000 people, and they've come to the conclusion, and the plant reflects that, obviously, and they've come to the conclusion that that's the best way to operate. So the long run average cost curve, labeled LAC or LRAC, curve shows the minimum cost per unit cost of producing each level of output when any desired scale of plant can be built. The long run average cost curve is given by a curve tangent. Please highlight that the long run average cost curve is tangent to all the short run cost curves that the company is looking at. So if they're looking at 4 different companies, 4 different plant sizes to build, they're going to have 4 different short run average cost curves representing all the alternative plant sizes that the firm could build in the long run. Remember, we're only in the planning stages here. The long run cost curve mathematically is the envelope that encloses all of the short run average cost curves. We'll show you that in a moment. So here we've got four different plant sizes that the company could build in the long run. So plant number 1 is represented by short run cost curve 1, plant number 2, short run average cost curve 2, and so forth with 3 and 4. And here is the table that goes with it. So you will notice that on the top, you've got short run cost curves 1, 2, 3, and 4. Then you have your quantities that the firm is productive enough or efficient enough to produce and the average costs. So plant number 1 is efficient from building 1 unit in a given time period down to 6 units in a given time period. And after that, it becomes inefficient. Plant size number 2 starts to be efficient at 3 units of output to 8 units. Anything less than 3, it's inefficient. Anything greater than 8, it is inefficient. Short run average cost curve number 3, the same thing. Anything less than 5, it's inefficient. Anything greater than 11, it's inefficient. And the same with plant plant size number 4. Anything less than 9, inefficient. Anything greater than 13, it's inefficient. You'll also notice that the short run average cost curve is U-shaped. It starts in plant number 1. It starts off very high at $20, drops down to $17, $15.55, bottoms out at $15 per unit in a given time period, and then it starts to rise again. All of these cost curves operate the same way. So the short run average cost curve is U-shaped. The more you produce, the costs will drop, they will drop to a minimum, and then they will start to rise. You have a series of these short run cost curve, and then you will draw a curve that is tangent, holding all of these short run cost curves together. That is your long run average cost curve. And let's take a look at it. Here is the long run average cost curves. You've got your 4 short run cost curves. The first one starts off high at $20 producing 1 unit. Then it drops to where you see the letter A at $17. It produces 2 units. And then it bottoms out at $15 and it produces 4 units. And then it starts to rise again. So at 5 units, it will cost $16 per unit on average. And then when you're producing 6 units, it has an average cost of 18. All of these short run cost curves are being considered by this firm. You will notice that the short run average cost curve, when producing 4 units of output, it would cost $15. That's correct. Then if you're producing, if you build plant size number 2, your average cost is going to drop to point B, where producing 4 units on average is going to cost you $13. That difference of $2 could be life or death. If you decide to build plant number 1 and build 4 units in a given time period, it's going to cost you $15. But if you build plant size number 2, it's only going to cost you $13. The 15 less the 13, that's a $2 discrepancy because you picked the wrong plant size. You should be building plant size number 2 when producing 4 units of output. And all the other curves are basically read the same way. So let's go back to the notes. So here's our table again, and let's continue. So if the firm expects to produce 2 units of output per unit of time, it will build a scale of the plant given in short run cost curve 1 and operate at point A, where the average cost is $17. If the firm expected to produce 4 units of output, it would build a scale of plant given by short run average cost curve 2 and would operate at point B, where your average cost is $13. Note that 4 units of output could also be produced at the lowest point on short run cost curve 1, but at the higher short run average cost of $15. Remember, you are starting off with problems here if you make that mistake in the planning stages. If the firm expected to produce 8 units of output, it would build the larger scale of plant indicated by short run cost curve number 3 and operate at point C. So if they were to produce 12 units of output, where would the firm operate? Well, if you go back to the table, producing 12 unit plant number 1 does not come into play. Plant number 2 does not come into play. Plant number 3 does not come into play. So if you're building 12 units of output, you would operate at that level at $12 right there. So the firm would operate at point D on the graph on short run cost curve number 4. By drawing a tangent to all of the short run cost curves, we get the long run average cost curve. So let's go back to the graph. And here we got it again. The long run average cost curve is the tangent to a series of short run cost curves. And in this diagram, it's labeled LAC, the long run average cost curve. Now let's go back. So the shape of the long run average cost curve. The short run average cost curve and the long run average cost curves in the previous diagram have been drawn U-shaped. The reason for their shape is quite different. You will recall that the short run cost curves at first, but eventually, the short run cost curves decline at first, but eventually rise because of the operation of the law of diminishing returns. We just went through the law of diminishing returns in the cost of production. And the reason for that is resulting from the existence of a fixed input in the short run. The short run always has at least one fixed factor of production, be it the size of the plant, be it the size of the farm that the farmer has, whatever the case is. In the long run, there are no fixed inputs. In the long run, as stated earlier, everything is a variable. Nothing is fixed. And the shape of the long run average cost curve is determined by economies and diseconomies of scale. That is, as output expands from very low levels, increasing returns to scale cause the long run average cost curve to decline initially. It will run into problems. But as output becomes greater and greater, diseconomies of scale may become prevalent, causing the long run average cost curve to start to rise. Empirical studies seem to indicate that for some firms, the long run average cost curve is either U-shaped and has a flat bottom, which implies constant returns to scale over a wide range of output. So your U becomes very, very elongated, falls down and then flattens out for a long period of time and then starts to increase on the other side. Or they can be L-shaped, indicating that over an observed level of output, there are no diseconomies of scale. So the long run cost curve falls, and then it falls flat and continues along forever, giving them constant returns to scale. So problem number 1, what is the relationship between the long run and the short run? And part B, how can the long run cost curve be derived? So the answer for question number 1, what is the relationship between the long run and the short run? The long run can be viewed as the time period for which the firm plans. Please remember that the long run can be considered the planning stages. So the firm plans ahead to build the most appropriate scale of plant to produce the anticipated future level of output. But once the firm has built a particular scale of plant, it is automatically in the short run. It cannot change its output very easily. There are other costs involved. So the firm plans in the long run. Once it starts to build, once it puts the shovel into the ground and starts to build their plan, they're automatically in the short run. And thus we can say that the firm operates in the short run and plans for the long run. The implementation of these long run plans determines the particular short run situation in which the firm operates in the future. And for question number B, the long run average cost curve is the envelope, that curve that holds all of the short run cost curves together. So it is the envelope of all of the short run cost curves and shows the minimum per unit cost of producing each level of output. Please note that in the diagram, for output smaller than 8 units per time period, the long run average cost curve is tangent to the short run average cost curve on the left side of their minimum point. For output greater than 8 units of for output greater than 8 units, the long run average cost curve is tangent to the short run average cost curve on the right side of the minimum points of the short run average cost curve. At an output level of 8 units, the long run average cost curve is tangent to the short run average cost curve number 3 at its minimum point. That is an important factor, and we'll get to it right here. This is also the minimum point on the long run average cost curve. The scale of the plant whose short run average cost curve formed the minimum point on the long run average cost curve is called the optimal scale of plant. Please highlight bullet point number 2. While the minimum point on any short run average cost curve is referred to as the optimal rate of output for that particular plant. So on the short run average cost curve, the minimum point is the optimal rate of output for that particular plant. And the minimum point on the long run average cost curve is the optimal scale of plant. Now we're getting into the long run marginal cost curve. Once again, the marginal analysis is recorded in the middle. The long run marginal cost curve measures the change in the long run total cost per unit change in output. The long run total cost for any level of output can be obtained by multiplying output by the long run average cost. So you get your long run total cost is equal to output Q times the long run average cost. By plotting the long run marginal cost curves midway between successive levels of output and joining these points, we will get the long run marginal cost curve. The long run marginal cost curve is U-shaped and reaches its minimum point before the long run cost curve reaches its minimum point. The rising portion of the long run marginal cost curve goes through the lowest point on the long run average cost curve. You have your notes, which appeared in the handout or on eConestoga under the heading Material from March 16 onwards. From here on in the long run average cost curve section, there are problems that you can read through. So please make a copy of these notes and go through them. And also, once again, don't forget your textbook. Chapter 9 has the short run average cost curves and the long run average cost curves. And please practice in my econ lab. Once again, good night, stay healthy, and we'll see you come September. No, sorry.